Okay, so this video is over an introduction of exponential functions. Exponential functions, it's the product of an initial amount and a constant ratio raised to a power. They are modeled using f of x equals a times bx, where a is a non-zero constant, b is greater than 0, and b does not equal 0. So in f of x equals a times b to the x power, a is your initial amount and b is your constant ratio. Asymptote is a line that a graph approaches as you move away from the origin, but it never reaches it. Some key features you need to know: domain, range, y-intercept, and asymptote. So the first few, we're just going to graph the functions and state the key features. So I have f of x equals 5x. So the first thing I'm going to do is I'm just going to kind of make a t-chart or a table, if you will. So I have x, f of x, which is also y, and I'm going to have -2, -1, 0, 1, 2. This is typically what you plug in for your x. So I have 5 to the -2 power. If we go to our decimals or our calculator, 5 to the -2 power, we get 0.4. Then 5 to the -1 is going to be 1/5. 5 to the 0 power is 1. 5 to the first power is 5, and 5 to the second power is 25. So now we're going to graph this. So I'm going to go to -2 and barely above the -2. It's kind of hard to see on this one. Let's go here. Then I have -1 1/5, so just barely above it. Again, this is kind of hard to show. And then you have 0, 1, 1, 5, and then 225 would be completely up there. And so then you have it like this. Your domain is going to be all real numbers, because if you were to graph, or you were to pull that graph down to your x-axis, it would hit every single x value. Your y-intercept is where it crosses the y-axis, so it's 0, 1. And then your asymptote is y equals 0. It approaches y equals 0, but never quite hits it. So then your range is y is greater than 0. Eventually your asymptote can change, so that will be in the transformation portion. All right, so this is a growth, just so you are aware. The function increases as x decreases. As x increases. So it's a growth. Moving along to the second problem. Okay, so now we have f of x equals 2 times 1/5 to the x power. So I'm going to do the same thing. And so we're going to go into the decimals, and I have 2 times 1 divided by 5 to the x, or 1 due to the -2. that equals 50. We're definitely not going to be graphing that. Let's do to the -1. That's 10. 2 to the 0, or to the 0 power, is 2. To the first power is 0.4. And to the second power is 0.08. So now we're going to graph this. So obviously -2 to the 50, that's not going to work. -1 to the 10th, 1, 2, 3, 4, 5, 6, 7, 10. And then 0 to the 2, 1 to the 0.4, and 2. Look like that. Your domain, again, is all real numbers. Your range, well, let's do y-intercept is 0, 2. Your asymptote is y equals 0. So your range is going to be y is greater than 0. Okay, so we're writing an equation for the function. So remember our equation's f of x equals a times bx. A is our initial value or our y-intercept, and b is our constant ratio. So my a for this one would be 8. And then I would have to do 4 divided by 2 gives me 2. 8 divided by 4 gives me 2. 16 divided by 8 gives me 2. So my ratio, my b, is 2. So my equation is f of x equals 8 times 2 to the x power. Okay, now let's look at this one. I have my initial, my a is 1. So I'm going to have 1/4 divided by 1/4. 1 divided by 1/4. 4 divided by 1, and 16 divided by 4. So this is all being multiplied by 4. So my b would be 4. So f of x equals 1 times 4 to the x, so it would just be f of x equals 4x. Now finally I'm given a graph and I need to write the equation from the graph. So again, I have my initial value, which is 8. It's where my y-intercept is. And then I'm going to look to see, so I have f of x equals a to bx. So right now I have f of x equals 8b to the x. So to find what my b is easily, I am going to I'm going to use this 0.14 and plug that in for x and f of x. So I have 4 equals 8b to the first power. So then I can divide by 8. So 1/2 equals b. So I'm going to have f of x equals 8 times 1/2 to the x power. And there you have it.